They lied to you about the golden age of steam. You've been sold a polished, romanticized narrative of whistleblowing glory and industrial triumph, where every rivet was a testament to American genius and every engine a conqueror of the continent. But that is a curated fantasy designed to sell tickets and stock options. The reality of the railroad wars wasn't just progress. It was a graveyard of hubris, littered with machines that shouldn't have existed. There is one specific locomotive, a leviathan of steel and ego, that the rail barons desperately wanted you to forget. A machine so catastrophically flawed, so dangerously ambitious, that its existence threatened to humiliate the most powerful engineering firm on Earth. This isn't just a story about a broken train. It is the autopsy of an industrial cover-up. You're watching Rust and Thunder, where iron tells the truth. If you value this depth of analysis, subscribing ensures you don't miss the next investigation. To understand why this machine was buried, you have to understand the desperation of 1913. This was not a time of careful calculation. It was an era of brute force. The Erie Railroad was suffocating under the weight of its own cargo. They were moving coal out of Pennsylvania, millions of tons of black rock that needed to traverse the Susquehanna Division, a stretch of track notorious for gradients that broke standard engines. The logic of the day was simple. If one engine isn't enough, use two. If two aren't enough, use three. But standard double-heading was expensive. It required multiple crews, coordinated braking systems, and wasted fuel. The Erie executives didn't want more trains. They wanted a monster. They wanted a single machine capable of doing the work of three, a pusher engine that could shove a mile-long coal drag up a mountain without gasping for air. They turned to the Baldwin Locomotive Works in Philadelphia, the Vatican of steam engineering. Baldwin was the premier builder, the company that set the standard for the world. But in the pursuit of the Erie contract, Baldwin's engineers abandoned the laws of thermodynamics in favor of pure, unadulterated scale. They proposed a design that looked less like a vehicle and more like a rolling factory. It was officially designated the P1 class, but history remembers it as the triplex. The concept was George R. Henderson's, a patent engineer who looked at the limits of rigid frames and decided they didn't apply to him. Standard articulated locomotives, the mallets, had two sets of driving wheels under the boiler. Henderson proposed three separate engines, 24 driving wheels, all fed by a single boiler. It was a design of staggering complexity. The third set of drivers wasn't even under the locomotive itself. It was placed under the tender, the car carrying the fuel and water. This meant the engine was effectively pushing and pulling itself simultaneously, a snake eating its own tail in a loop of mechanical violence. On paper, it was the most powerful land vehicle ever conceived. In reality, it was a physics equation that couldn't possibly balance. The construction of the first unit, number 5014, named the Matt H. Shea, became a spectacle of excess. Inside the Baldwin shops, the workers had never seen castings of this magnitude. The frame alone stretched over 100 feet. When the boiler was lowered onto the chassis, the shop floor literally groaned under the weight. This wasn't just an engine. It was 853,000 pounds of iron and intent. The cylinders were massive, designed to gulp steam at a rate no firebox had ever been asked to sustain. And that was the first crack in the armor, the detail the engineers glossed over in their rush to break records. A steam locomotive is, at its core, a balance between heat generation and steam consumption. You burn coal to boil water, creating pressure to move pistons. If you have too many pistons and not enough fire, you run out of breath. The triplex had 6 massive cylinders. It had the tractive effort to pull a skyscraper off its foundation, theoretically producing over 160,000 pounds of force. But to feed those 6 cylinders, the boiler needed to produce steam like a volcano. Baldwin's engineers bet everything on the idea that the sheer size of the firebox would compensate for the volume of steam required. They were wrong. They were catastrophically, embarrassingly wrong. As the Matt H. Shea took shape, it became a celebrity. The press hailed it as the centipede, a king of the rails that would render all other engines obsolete. It was painted, polished, and paraded before the public. It was the Titanic of the rails, too big to fail, too advanced to falter. But the men who built it, the veteran boilermakers and the fitters who tightened the thousands of stay bolts, they saw the problem. They looked at the great area of the firebox, massive as it was, and then looked at the miles of piping leading to the tender cylinders. They knew that steam loses heat as it travels. By the time the steam reached the rear set of drivers under the tender, it would be cooling, losing pressure, turning back into water. They were building a machine that would choke on its own complexity. When number 5014 was finally rolled out into the Pennsylvania sunlight in 1914, the ground shook. It was a terrifying sight, a wall of black steel that blocked out the sun. The Erie Railroad immediately put it to the test on the Susquehanna grades. The plan was for the triplex to push heavy freights up the hill, replacing 3 standard helpers. The crew climbed into the cab, a space that felt more like the bridge of a battleship than a train. The fireman looked into the firebox, a cavernous hell that would require him to shovel coal continuously, without pause, just to keep the pressure needle moving. The first tests were deceptively promising. At low speeds, with the throttle cracked open, the triplex moved. It possessed a low-end grunt that was undeniable. It could start a train that was welded to the tracks with rust. But the moment the engineer opened the throttle wide, the moment he asked the beast to run, the design flaw revealed itself with brutal immediacy. The exhaust from the front 2 sets of cylinders was routed through the smokestack to create a draft for the fire, a standard practice. But the exhaust from the rear set, the tender engine, was vented out the back. This meant the fire wasn't getting enough draft. The harder the engine worked, the more steam it used, but the fire didn't burn hotter to replace it. Within minutes of a heavy haul, the pressure gauge would begin a death spiral. The boiler was being drained faster than the water could boil. The Matt H. Shea wasn't a locomotive. It was a steam vampire. It would roar with tremendous power for 10 minutes, tearing up the grade, and then, inevitably, it would begin to die. The speed would drop. The massive wheels would slip. The fireman would be shoveling until his muscles failed. But the needle wouldn't rise. The most powerful engine in the world was suffering from asthma. But the Erie Railroad had already committed. They had spent a fortune. They couldn't just scrap it. They had to make it work. They ordered the crews to push harder. They modified the grate, they tweaked the exhaust nozzles, they tried every trick in the book to keep the pressure up. But you cannot engineer your way out of bad physics. The triplex became a nightmare for the crews assigned to it. It was hot, loud, and unpredictable. The tender, which carried the fuel, emptied at an alarming rate, and as it got lighter, the rear wheels lost traction. Since the rear engine was under the tender, as the coal and water were consumed, the weight over those wheels decreased. The result was a slip of violent proportions. Imagine 8 massive steel wheels spinning wildly under a tank of water, shaking the entire train, threatening to tear the tender apart from the sheer vibration. The Matt H. Shea was quickly becoming a liability. It was slow, painfully slow. Its top speed was barely 10 miles per hour because the boiler simply couldn't produce enough steam to go faster. It was a specialized tool that was too specialized to be useful. It couldn't be used for mainline freight. It was strictly a pusher, a beast of burden tethered to the steepest hills. And even there, it was failing. But Baldwin and Erie weren't done. In a display of stubbornness that defies logic, they didn't cancel the project. They didn't admit defeat. Instead, they doubled down. They ordered 2 more. This is where the story shifts from engineering failure to corporate delusion. Why build more of a machine that doesn't work? Because to stop would be to admit that the fundamental concept, the very idea of the triplex, was a lie. And in 1916, with the world looking toward war and efficiency becoming a religion, no one wanted to admit they had built a god that couldn't breathe. They built numbers 5015 and 5016, minor refinements on a broken idea, hoping that somehow the metal would learn to obey them. They were wrong again. The tragedy of the triplex wasn't just that it failed. It was that it was allowed to fail for so long, consuming resources and manpower in a desperate attempt to prove that bigger was always better. The erasure of this failure started slowly, not with a public announcement, but with a quiet reassignment to the scrap lines. But before the torches could cut them apart, the triplex had one final lesson to teach the industry, a lesson written in twisted metal and lost fortunes. Stop believing the myth that innovation is always progress. In the world of heavy rail, innovation is often just a mask for desperation. The triplex was a disaster, yes, but what came next wasn't an improvement. It was a denial of reality so profound it bankrupted budgets and ruined careers. The industry looked at the smoking wreckage of earlier super locomotives and didn't see a warning. They saw a challenge. They convinced themselves that the concept wasn't flawed, just the execution. And this arrogance birthed a new generation of mechanical monsters that were designed to fail before the first rivet was ever driven. The context here is critical, and it is something the history books often gloss over in favor of shiny photographs of streamlined casing. By the late 1940s, the diesel engine was already proving itself to be the superior predator. It was cleaner, it offered higher availability, and it didn't require an army of men to maintain. But the major coal-hauling railroads, the Chesapeake and Ohio, the Norfolk and Western, the Pennsylvania, were financially and politically married to the coal industry. They couldn't just switch to diesel without declaring war on their biggest customers. So, they forced their engineers to do the impossible: build a coal-burning locomotive that acted like a diesel. They were trying to force an obsolete fuel source into a futuristic package, and the result was the Chesapeake and Ohio M1 steam turbine. If the triplex was a brute, the M1 was a deception. On the outside, it looked sleek, modern, and capable. It was the longest single-unit locomotive ever built, stretching over 154 feet. It didn't chug. It hummed. It carried a steam turbine power plant on its back, generating electricity to drive traction motors. It was a rolling power station, a technological marvel that promised to save the coal industry from extinction. But beneath that bright orange cowling lay a labyrinth of plumbing and wiring so complex that it virtually guaranteed failure. The design philosophy was built on a fallacy. The engineers believed they could take the delicate, high-precision technology of a stationary power plant technology designed to sit on a concrete foundation in a dust-free room and mount it on a steel frame that would be subjected to the violent vibrations, dirt, and impacts of the American railroad track. It was hubris in its purest form. When the M1 finally hit the rails in 1947, the reality shattered the marketing pitch almost instantly. The locomotive was designed for a high-speed luxury passenger service called the Chessie, a train so opulent it was supposed to redefine travel. But the M1 was so unreliable that the train it was built to pull was canceled before it ever entered service. The locomotive was an orphan from the moment it was born. The problems were visceral and immediate. The steam turbine required a massive amount of air for cooling, but because the engine sat directly behind the coal bunker, the air intakes sucked in clouds of coal dust. This dust coated the electrical contacts, shorted out the traction motors, and turned the engine room into a gritty, conductive nightmare. The crew wasn't spared either. The heat inside the cab was unbearable, often unrelated to the weather outside, as the boiler and turbine radiated thermal energy that had nowhere to go. It was a miserable, deafening, dirty place to work, hidden inside a shell that looked like a spaceship. We spend weeks digging through obscure maintenance logs and forgotten engineering reports to piece together the true operational history of machines like the M1. If you value this kind of deep-dive industrial archaeology, subscribing ensures you don't miss the next investigation into the archives of failure. The railroads tried to fix it, of course. They threw money at the problem, modifying the intakes, tweaking the turbine blades, and adjusting the boiler pressure. But you cannot engineer your way out of a fundamental misunderstanding of the environment. The M1 was a delicate watch trying to function inside a cement mixer. The coal dust was relentless. The vibration cracked pipes. The water consumption was astronomical. But the most damning failure was the silence that followed. Usually, when a locomotive class fails, it is relegated to helper service or local freight. It spends 20 years working off its debt in the background. The M1 was so catastrophic that the C&O gave up in less than 3 years. 3 years. For a machine that cost millions in today's money. In 1950, the order came down to scrap them. And this is where the erasure becomes literal. They didn't just scrap them. They obliterated them. Not a single unit was saved. No museum piece, no monument to the attempt. The C&O wanted the M1 gone so completely that today, we only have photographs and blueprints to prove it ever existed. They were embarrassed. They had bet the farm on a technology that didn't just fail. It humiliated them in front of the diesel salesmen who were waiting at the roundhouse doors with contracts in hand. But the industry wasn't done bleeding yet. The obsession with the steam turbine didn't die with the M1. It mutated. The Norfolk and Western, perhaps the most stubborn of all the coal roads, looked at the failure of the C&O and said, "We can do it better." They built the John Henry, a steam turbine electric that looked less like a train and more like a brick of pure industrial stubbornness. The John Henry was designed to solve the problems of the M1 by using a high-pressure water tube boiler, similar to what you would find on a battleship. It operated at 600 psi, double the pressure of a standard steam locomotive. Theoretically, this was the answer. In practice, it was a bomb waiting to go off. The control systems required to manage that kind of pressure were incredibly complex, utilizing automated controls that were in their infancy. The result was a machine that required a technician in the cab alongside the engineer and fireman just to interpret the warning lights. It was efficient when it worked, hauling massive tonnage with less fuel than a conventional steamer. But it rarely worked for long. The feed water pumps failed. The controls shorted out. The vibration rattled delicate sensors into uselessness. The crew hated it. It was loud, unpredictable, and dangerous. There is a pattern here that defines this era of erasure. The railroads were not just building bad engines. They were building engines that required a level of maintenance and care that simply did not exist in the rough-and-tumble world of freight logistics. They were trying to perform surgery with a sledgehammer. The John Henry, like the M1, was quietly pulled from service and cut up for scrap. The N&W, famous for its steam prowess, didn't want a reminder of the time they tried to outsmart the diesel and lost. These machines weren't just mechanical failures. They were financial black holes. Every dollar spent on trying to make the steam turbine work was a dollar not spent on upgrading track, improving signaling, or buying the diesels that were clearly the future. The executives were paralyzed by the sunk cost fallacy. They had spent decades building infrastructure for steam, water towers, coaling stations, roundhouses. They couldn't accept that all of it was about to become worthless. So they built the M1 and the John Henry and the Pennsylvania S2, hoping for a miracle that physics refused to grant. The erasure of these locomotives serves a specific purpose. It protects the legacy of the Golden Age. We like to remember the railroads as titans of industry, moving the nation with precision and power. We don't like to remember the panic. We don't like to remember the boardrooms filled with smoke and fear, authorizing the construction of steel leviathans that were obsolete before the ink was dry on the blueprints. The M1 and the John Henry are the ghosts of that panic. They are the evidence that the transition from steam to diesel wasn't a smooth handover of power. It was a violent, expensive, and desperate struggle for survival. And yet, even as the turbines were being cut apart in the scrap yards, one final, even more bizarre attempt was being concocted. The engineers, refusing to admit defeat, decided that if coal couldn't power a turbine efficiently, perhaps they should look at the technology falling out of the sky. The jet age was dawning, and the railroads, in their infinite wisdom, decided to strap a jet engine to a set of wheels. This wasn't just a failure of engineering. It was a failure of sanity. But sanity has never been a prerequisite for the New York Central Railroad when survival is on the line. You need to understand the sheer desperation of this moment. They didn't just want to go faster. They wanted to scream their relevance into the face of a dying industry. So they took a standard self-propelled Budd RDC commuter car, a vehicle designed for polite, slow trips between suburbs, and they mounted two General Electric J47-19 jet engines directly onto the roof. These were the same engines used on the B-36 Peacemaker bomber. This wasn't engineering. This was a hostage situation where the hostage was physics. They called it the M497 Black Beetle. It looked like a metal insect wearing a jetpack, a grotesque hybridization of 19th-century rail infrastructure and Cold War aerospace surplus. In July 1966, on a stretch of track outside Bryan, Ohio, they fired it up. The sound was not the rhythmic chug of a diesel or the hiss of steam. It was a deafening, high-pitched shriek that shattered windows and terrified livestock for miles. The Black Beetle didn't roll. It was thrust forward by 5,000 pounds of force, tearing down tracks that were never designed for such violence. It hit 183 miles per hour. It holds the U.S. rail speed record to this day. And yet, almost immediately after proving it could be done, the railroad buried it. Why? Because it was useless. The wind blast from the engines tore up the gravel ballast between the ties. The fuel consumption was astronomical. The noise was illegal in every municipality it passed through. It was a spectacular, fire-breathing stunt that proved exactly one thing. Just because you can strap a missile to a wagon doesn't mean you have a transportation strategy. They stripped the engines off, returned the car to commuter service, and pretended the whole fever dream never happened. The data was filed away, the photos were kept as curiosities, but the initiative was suffocated in the cradle. But the infection had already spread. The United Aircraft Corporation, seeing the railroads floundering, decided that if New York Central could bolt engines to a roof, they could design a train that was effectively a fuselage on bogies. They gave us the turbo train. This wasn't a retrofit. It was a ground-up attempt to turn a train into a low-flying aircraft. It used gas turbine engines, aluminum construction, and a suspension system based on a pendulum to swing the cars through curves, allowing for higher speeds on old, twisted tracks. On paper, it was the future. In reality, it was a mechanical nightmare. The turbo train was fast, hitting 170 miles per hour during tests, but it was fragile. In the brutal winters of Canada and the northeastern United States, the complex intakes clogged with snow. The electrical systems, far too advanced for the damp, dirty reality of railroad maintenance, shorted out constantly. But the real killer was the fire. On a press run, the turbo train actually caught fire, forcing dignitaries to evacuate. The brakes would freeze, the heating would fail, and the ride quality was erratic. It was a spaceship trying to navigate a mule track. The railroads, realizing they had purchased a fleet of maintenance-heavy divas, began to quietly sideline them. They ran them until they broke, and then they didn't fix them. Across the Atlantic, the British were suffering from the same delusion with their advanced passenger train, the APT. They spent millions developing a tilting train that could take corners at speed without spilling the tea. The engineering was brilliant, but the execution was a disaster. The tilt mechanism was so efficient, so perfectly compensated, that it completely detached the passengers from the visual reality of the turn. Their eyes saw the horizon tilt, but their inner ears felt nothing. The result was mass motion sickness. They built a train that made its passengers vomit. The press dubbed it Queasy Rider, and the reputation of the British Rail Engineering Department was destroyed overnight. The prototypes were hauled away to the scrapyards, cut up under the cover of gray skies, and the technology was sold off to the Italians, who actually made it work decades later as the Pendolino. This is the phase of history the railroads want you to forget. They want you to see the sleek lines of the modern Acela or the TGV and imagine a straight line of progress. They don't want you to see the graveyards filled with turbine-powered failures and jet engine monstrosities. There is a concerted effort to sanitize the timeline, to present the industry as a rational actor. But if you look at the rust piles and the forgotten sidings, you see the truth. You see a panic-stricken industry throwing money at the wall to see what would stick. If you believe that these mechanical monsters deserve to be remembered rather than rusted away in silence, showing your support for this archive helps us keep digging through the blueprints they tried to burn. The erasure was thorough. Most of the turbo trains were scrapped. The Black Beetle was gutted. The experimental steam turbines like the John Henry were cut into pieces so small you couldn't identify them. The railroads returned to the diesel-electric locomotive not because it was exciting, but because it was boring. It worked. It was heavy, reliable, fuel-efficient, and didn't set the countryside on fire. The failure of sanity was replaced by a rigid, unyielding pragmatism. But we lost something in that correction. We lost the audacity of the error. When you look at a modern freight train dragging a mile of containers at 50 miles per hour, it is a triumph of logistics, but it is a graveyard of imagination. The locomotives we have today are the survivors, the evolutionary winners that outlasted the freaks and the mutants. But those mutants, the steam turbines, the coal dust burners, the jet-powered commuter cars, they tell the real story of the railroad. They tell the story of an industry that refused to die quietly, that was willing to break the laws of physics and common sense just to stay relevant for one more decade. The locomotive railroads tried to erase isn't a single engine. It is an entire generation of machines that were too loud, too fast, and too complex for this world. They were the dinosaurs looking up at the meteor, baring their teeth and roaring one last time before the climate changed forever. We walk on the tracks they built, but we rarely hear the echo of their turbines. The history books might be clean, but the rust never lies. The failure wasn't that they tried to fly. The failure was that for a brief, terrifying moment they actually did. And then the industry woke up, checked the ledger, and decided that the ground was the only place they could afford to be.